Hello, friends. I am here to talk about ScrapSheets. Let's talk about the elephant in the room. Spreadsheets, they are cool. We think they are cool. There's only so many ways to regularly and periodically tile a plane. Rectangles is a good way to tile a plane. Therefore, we end up always converging back to something spreadsheet-like, right? Like there's mathematical, yeah, the carcinization, yeah, the crabs, dude, it's the crabs in the spreadsheet. Lots of other nice features. We'll save those for later. Not cool. Spreadsheets are also not cool. At least the current implementations. There's a lot to be desired. I have been thinking about this a lot, and so I am here to grow the graveyard of better spreadsheets. The first version, which the reviewers very much did not like. Pretty much the main idea that I wanted to experiment with is that spreadsheets, you only have one cell to work with at a time, and I really wanted to work with lots of cells at a time. I wanted to work with the regions and make regions that produce other regions and stuff like this. So this was the kind of original thing. But working with regions, you need space to work with. So I made this thing called a buffer, and you can write arbitrary code in the bottom and manipulate your buffer and paste it back in. One thing you'll find, though, is you don't want to work in the buffer. You want rules to be applied in liveness. You want some liveness there. And so you can add code on the side that automatically applies to the main spreadsheet. One other thing is you want data from the outside. So if you look at the top, there's a little counter going on. That's just a counter from the outside, but you can use HTTP, whatever, get it in there. Also added search in here. Search is a nice thing. You don't always want a rectangular shape. Your data is not always rectangular. You sometimes want to search for things, and so you can both search for things, and you can make rules that target those searched things. And this is an example where I take Pluto, and if it finds Pluto, it erases it because Pluto is not a planet. And because you can write to the region itself, you can get something that look at the Citizen Kane right here. Look at this Conway's Game of Life. You write to the cell below it, and it looks like it moves over time. Anyway, what I made is not cool. I'm glad I did it, but there were a lot of things that just did not feel nice. I tried making some like real spreadsheet type stuff, and it broke a lot, like not great. So we're to 2.0, back to the drawing board. This is kind of my rough idea for the next thing. I liked the rules idea, but the rules, I wanted to co-locate it with the data. And because when you really use spreadsheets, you're thinking about, okay, I have this little section over here, and it interacts with this. And so I kind of started with this next model, and it had a lot of nice properties, so I was pretty stoked. I will say to Ivan Reis that algebra is not an illusion. It's useful. Along the way, I started modeling some of this nasty async stuff with this little algebra that I created called Reactive Relational Algebra, because this new ScrapSheets 2.0 was nice, but the async stuff was really driving me wild. It was becoming unwieldy, and so I reactive relational algebra. This stuff is nice for modeling sets and tables and stuff over time. You can also do some nice little proofs. It's like, okay, if your operation commutes, then you can have like CRDTs or operational transforms in ScrapSheets 2.0. So nice little features of this. You can reference tables themselves, and I'll show you why that's nice in a second. You can use any relational algebra, but relational algebra is not fun. So I ported a lot of this into a nicer DSL on my programming language, ScrapScript. So this is what ScrapScript looks like. Anyway, I have a Elm implementation in the browser up on GitHub, and let's get to the demo of 2.0. So what we have here is we have these little table views, and you can add rows. The code side of things creates the data, and the data is also manipulable. Should I make it bigger? You can manipulate it here. One thing that, oh no, I want this here. If you look at the code here, these are all like basic SQL type things. People really like SQL and thinking about sets in that way. So yeah, you could do whatever SQL can. And here you have memory. If you union one of these sheets with itself, you can show what happened in the last time step. All right, so you can do some weird, cool stuff like that. This is grabbing a random number from the internet every 2 seconds or 1 second, and you can subscribe to this, and this will update in real time. And you can do some even cooler stuff with spreadsheets. Because you're operating on lots of groups of things, you can do something like this. This is Conway's Game of Life implemented in a spreadsheet program. And this over here is just some different reductions on this, counting how many exist in certain columns and stuff. So this is what I have right now. What are the next steps? Lots of fun stuff with undo and redo, with the relational algebra I have going on. There's a lot of provably nice things that you can do with undo and redo. There's a distinction between the code and the data. A lot of this is code-based and generating the little tables and stuff. There's a lot of remaining work to do on getting the data manipulations down into the code. LLMs, lots of fun stuff. Anyway, thank you guys.